Great. Well, good afternoon or good morning to you, wherever you are listening to us. My name is Dr. Margaret Whitaker. I'm the program co-chair of the A4, and we're wrapping up our 2022 webinar series with a webinar titled Circularity, the Role for Substitution Thinking. Next slide, please. So over the next hour, we're going to talk about substitution, but I'd like to spend just 20 seconds talking about the A4. I'd like you to participate in the A4, ideally as a member. If you're not ready to sign up as a member, you could sign up for our email list by going to the A4 website, scrolling down to the bottom right and click on our newsletter and our updates so that you get emails about great webinars like this occurring. For those of you who are current A4 members, we have elections going on for different positions until December 2nd. So we need your vote if you're a member. And we also want you to go onto our LinkedIn and Twitter pages to see what's new and what's happening. We're only as good as our members, so please participate either as a volunteer or as an elective officer. Next slide, please. So we have just two goals for today. I'm sure those of you who are American who had Thanksgiving, we're still getting over our holiday and our tryptophan high, so we're keeping it simple. We want to talk about a circular economy today. So in a circular economy, chemicals are needed for processes and products that are regenerative by design. Currently, our chemicals policy and economy is far from circular. Moving forward, substitution thinking will play an important role in identifying alternatives that better adhere to circularity principles. So here are our two goals. We want to gain insights from OECD reports and initiatives and learn about them to support the integration of sustainable chemistry and substitution thinking into the redesign and design of chemical intensive products and processes. And then we've got time today in the webinar. We want to hear from you. We want to hear about how substitution is playing a role in your company's journey towards these circularity goals. Next slide. So I'd like to present Dr. Eva Lanala, and hopefully I didn't butcher that one too much. She's the principal administrator for programs on risk management, good laboratory practices, and mutual acceptance of data at the OECD. So she collaborates with OECD member countries and stakeholders to advance approaches for risk reduction of chemicals, including substitution and sustainable chemistry, as well as leading the program on good laboratory practices and mutual acceptance of data. Before the OECD, she led the hazard assessment program at the OECD. And prior to the OECD, she also worked in the area of chemical management at Health Canada for 12 years. She holds a PhD in biochemistry from Queen's University in Canada. So let's just go over some quick logistics. Next slide. So we are using Zoom meeting. So please keep your lines muted and your videos off during the portion of the presentation. Use speaker view in Zoom. It's going to offer you the best viewing experience. And during the Q&A portion of the session, if you'd like to answer a question or offer a comment, please raise your hand, and I'll show you how to do that in the next slide. So you can unmute your line during that time and turn on your video to engage with us at the time. And then if you'd rather, you can also use the chat. We'll be monitoring comments on the chat session. We're recording the session and we'll post it on the A4 website. And we also have an inventory of resources described in the webinar that we'll also post on the A4 website. Next slide. So I think most of us are familiar with Zoom. If you haven't used it before, to raise your hand, open the little reactions button. I know you want to hit that hard, but instead hit the raise hand button. Please lower your hand button afterwards so the next person can go. And as I said, the chat function will work also. Next slide. So with that, I'm going to turn my video off and I'm looking forward to the presentation. Go for it.
Great. Thank you, Meg, for the introduction. And also thank you to A4 for inviting me today to give you some perspectives and thinking on the role of substitution and alternatives assessment thinking in the concept of circularity. So I'll be giving you an introductory presentation, which also tries to link to some of the OECD work that touches upon this area. But then, as was said in the introduction, that we'd also like to hear from you as to where you think substitution and alternatives assessment can play a role in circularity. And so look forward to hearing your input on that as well after the presentation. So first, I'll just start with a bit of, oops, okay, sorry, I'm just trying to get the mouse control. I think it's starting to work. Okay, so just a bit of an introduction on the OECD. So the OECD is an international organization. It was founded back in 1961 and it now includes 38 countries. And really, the main goal of the organization is to build better policies for better lives. And we work through a structure of ambassadors and then also committees and working parties, which have country representatives on them to direct the work. And then the Secretariat supports the different initiatives. So in terms of the work of the chemicals program, it's called the OECD Environment, Health and Safety Program, but this is really where the work on chemical safety and biosafety takes place. And here's where we work with member countries, but also partner countries and other stakeholders to improve the human health and environmental impacts of chemicals, but also at the same time to make chemical policies more transparent and efficient and save resources for governments and industry. And by harmonizing these approaches, there's also the added benefit of preventing unnecessary distortions in trade. And all of the information that's developed in the context of our chemical safety program is available on the OECD website. Within the chemicals program, one area that we've recently established is our working party on risk management. So working party is a group underneath our chemicals committee. And this brought together a number of different areas that we had been working on risk management at the OECD, but it really formalized this area of work in 2021. And as some of you that are on the call are aware, we've been working on the topic of substitution of chemicals for about 10 years and on sustainable chemistry, on various different ad hoc topics on sustainable chemistry for longer than that. And also, as part of this work area, there's activities on shifting to safer alternatives for PFAS substances, but also a growing area on working with countries to improve risk management tools and approaches, and including aspects of socioeconomic analysis. So if we now jump sort of into the content thing, if we think about traditional chemicals management process that most countries have in place, it's really has been a linear process, sort of simplistically looking at it in terms of having some information gathering that's followed by risk assessment, that's followed by risk management. And if we're fortunate, we get some interplay between these different areas and also include monitoring of the effectiveness of our risk management measures. But really, how are we doing in this area of chemicals management internationally? So under the strategic approach for international chemicals management, or SICM, there was a goal to have sound management of chemicals by 2020. So as has been recognized, the world did not meet this goal, and that policy framework is now being renegotiated. And also within the UN's Global Chemicals Outlook, it acknowledged that there's still a long way to go to meet this goal of sound management of chemicals. The Global Chemicals Outlook too also noted that this issue is not something that's going away. The size of the global chemical industry is expected to double by 2030. There's continuing release of hazardous chemicals and other pollutants. There's a definite cost of inaction to our slower management of chemicals. But it also notes that the chemical industry can also provide opportunities to advance sustainable consumption, production, and product innovation. So we have a longer way to go on chemicals management. And at the same time, there's been advances in other areas of environmental thinking, and in particular in the area of having a circular economy. So these are two depictions of what you can think about in terms of a circular economy, which was really driven from the aspect of minimizing resource use and minimizing extraction, and making resource use more circular. So from production to consumption to improving waste management and circulating waste back to resources. So on the left-hand side here, you see sort of a more simplistic diagram from the EU's first circular economy action plan that was launched in 2015. And on the right-hand side, a much more elaborate depiction of the different loops that could occur in a circular economy from the Ellen MacArthur Foundation. This one's sort of known as the butterfly diagram, and really depicting the circular aspects that could come into place from collection of different types of waste and their recirculation into different parts of the value chain. But as these circular economy plans and approaches were being created, there was also a growing recognition that we want these circles or these loops to be clean or free of the reintroduction of hazards into uses where they could not be properly managed. So this recognition that we also need to think about what is being circulated within these loops, in particular in terms of chemicals. So how can we better integrate this sort of linear chemicals management that we have with this more circular approach in a circular economy? Well, one way that can help is, sorry, I'm just trying to advance the slide, sorry, too far, is to be more proactive, have more proactive consideration of chemicals management at the design stage. So if we consider at an earlier design stage, we can influence environmental effects or environmental impacts all along the life cycle, from sourcing, manufacturing, processing, use, product, and down to end of life. So really moving from a model of chasing issues retroactively to try and proactively address chemicals management issues. So in relation to some OECD work that links to this, back in 2018, we held a global forum on the designing sustainable plastics from a chemicals perspective. And this was really driven by our chemicals committee looking at what value added we could bring from the chemicals aspect to ongoing discussions on the management of plastics. And on this project, we also collaborated with another OECD group that's focused on resource productivity and waste. So really bringing these communities together. And the discussion really focused on the design stage of plastics, and how better consideration of chemicals at the design stage can really influence the different environmental impacts along the life cycle. Again, from the source materials all the way down to the different end-of-life treatments. And after the discussion in 2018, countries really wanted to focus more on further developing the considerations for better design of plastics. So really this concept that when plastics is the material of choice, how can we design more sustainable plastics with a chemicals lens? So we set about to develop these considerations by conducting first a number of case studies to inform the considerations. So these are available on the OECD website, and they take a more of a deep dive into 4 different areas. So 2 on plastic packaging, biscuit wrappers and detergent bottles, and another 2 on construction material, on installation and flooring. And then from these case studies, we really look to draw the more general considerations. And also working with product designers to understand how this thinking can better be inserted into the design model that designers and engineers work with when they're designing new products. So to really fit this into thinking that designers are already comfortable with in their daily lives. So last December, we published this report, A Chemicals Perspective on Designing with Sustainable Plastics. And this was really about integrating sustainable chemistry thinking in the design process, and trying to communicate from the perspective of regulators and other stakeholders that we were working with, communicate to designers and engineers some of the complexities of designing sustainable plastics, and how to better think about chemicals at the design phase. And the document is really laid out into different layers of detail. So it draws upon the American Chemical Society's design principles of sustainable chemistry and engineering. So maximizing resource efficiency, eliminating and minimizing hazards and pollution, designing systems holistically, and using life cycle thinking. But then it goes on to detail it, in at a more granular level, some sustainable design goals. So really selecting materials with inherently low risk or hazard, having a commercial afterlife for the materials, using materials that generate no waste or minimizing waste, and where appropriate, selecting materials that use secondary feedstocks or bio-based feedstocks, knowing that there's also trade-offs in this area. And then finally, doing a further dive down into each life cycle phase to articulate different considerations that designers could take into account when selecting chemicals that might then influence other parts of the life cycle. And then, of course, looking at sort of whole product optimization. So this is really the idea that if we're thinking about chemicals, they then influence the materials, which influence the product, which are part of an entire systems approach. So this is how the chemical selection can really then influence a number of different aspects within the system. So if we go back to the diagram that I had earlier on, sorry, I'm having some problems going back and forth. There we go. So if we think about considering a whole systems approach and using life cycle thinking, then of course we'll have a number of different trade-offs between the different parts of the life cycle. So for example, a chemical, if you look at a chemical during its use phase, and potentially the selection of that chemical may lower some ecotoxicological hazards. But it could be that the use of that particular chemical would inhibit recycling, or it could be that the use of that chemical would then require in the product manufacturing stage for additional energy or additional water use. So really looking across the life cycle brings out a number of these trade-offs, and it plays a number of different policy elements across each other. But ultimately, even though the complexity is increased, if designers are thinking about these various trade-offs that could happen based on their selection, then ultimately we should end up with better and more transparent decision making. So going sort of back to chemical substitution and alternatives assessment. So if we're thinking about substitution is in response to a regulatory activity, for example, a certain chemical is restricted or banned and we want to find a substitute, or if there's innovation of a new chemical material or product, or if we're designing or redesigning a new product, or there's a process change. These are all different chemical selection decisions that are being made. And so this is why I think that the decades of experience in the area of assessment alternatives really has a lot to bring to all of these different discussions where we're looking more at circularity of materials and how chemicals can influence the circularity. Because a number of these decision frameworks and decision analysis approaches that have been developed in the area of alternatives assessment and substitution can really inform these chemical selection decisions that are part of all of these processes. So I wanted to also bring up another OECD guidance document that we developed about 2 years ago now, a little less than 2 years ago now, on guidance on key considerations for identification and selection of safer alternatives. So here, the goal was really to try to come to a common approach for defining what a safer chemical was in the context of alternative assessment, recognizing that there are, of course, and this audience is well aware, a number of different frameworks and approaches for alternatives assessment. But could we have, amongst countries and other stakeholders, a consistent understanding of what the minimum requirements were to determine whether an alternative is safer or not? And so this is what this document really articulates. And now as we see the advances, in the discussions on things like circularity or safe by design or safe and sustainable by design, countries have raised, can we move also in the context of our work to not just looking at what is a safer chemical, but what are different attributes that could also be considered in addition to the safer aspect in terms of decision making or chemical selection considerations. And I think it's really sort of finding a balance between alternatives assessment and then going all the way to complete life cycle assessment, because of course, life cycle assessments consider a number of different attributes and depending on the frameworks include more or less on chemical safety as well. But this is some of the thinking of where countries are considering to take this work. But and we'll be hoping to hear from a number of participants online today. But I think a number of companies are already doing this. So not just considering safety aspects when they're selecting chemical alternatives, but also other attributes that might be related to climate change or resource productivity or resource use or things like recycling or end of life or making a substance or product more circular. But of course, there's a number of other tools that the alternatives assessment community has created and collated over time. This is just one example of the OECD Substitution and Alternatives Assessment Toolbox, where we brought together over the years a number of different tools that could support substitution and alternatives assessment, whether these be hazard assessment tools or data sources, different case studies. But we had already, when this was really focused on substitution and alternatives assessment, collected a number of other frameworks or guides or toolkits that went a bit beyond the beyond looking at the main attributes that are usually considered in substitution or alternatives assessment. So these are definitely resources and areas where that can be built upon as we start looking at broader circularity or sustainability considerations in these chemical selection decisions. So just a couple final thoughts here before we open it up for some conversation. So what are some potential policy solutions that would make chemicals management more sustainable? Well, if you think about our chemical management frameworks, one idea is, as I mentioned earlier, is to integrate this more proactive chemicals management thinking within the frameworks. So more sustainable design, use of greener chemistries. Also bringing in life cycle thinking aspects to understand what are some of the trade-offs. So of course, in most chemicals management frameworks, we're really making decisions about chemical risk and safety, but what are how are some of those decisions implicated then in other environmental questions? There's also this aspect of linking risk management and innovation. Often there's the thinking that a response to regulatory risk management and chemical substitution is quite different from the thinking that occurs at innovation. But really, I think we want to be thinking about how we align this more so that the innovation that we have to alternatives to chemicals that are being regulated are not likely to be risk managed in the future, and so how we insert this sort of proactive thinking. Of course, it's good to think about increasing financial measures and support for things like sustainable chemistry, thinking about how different economic instruments could be used to incentivize sustainable substitution, and also in terms of education, integrating more knowledge of toxicology and environmental health into chemistry and engineering programs. And of course, UNEP will be releasing a publication sometime in the short term on just this aspect of education and sustainable chemistry. So with that, I think I'll just end here with a couple of links that will be shared with you afterwards on some of the OECD reports that I've mentioned. But all of this information is available through our chemical safety website. And with that, I'd like to thank again the A4 community for inviting me to provide this introductory presentation today on how substitution can play a role in circular economy, and again, looking to hear your views as we move into the next part of the discussion. Thank you.
Eva, thank you so much. Your work brings together so many different threads of policies, tools, frameworks, and you are in a community that's not always engaged with by people from industry and academia. So it's a real treat to have you here today. Thank you for sharing your experiences and your resources. And we're excited to have a discussion. My name's Lauren Hine. I'm co-chair with Dr. Margaret Whitaker of the program committee, and with Molly as well. So we'd like to open this for discussion. We're open to questions. If you want to put a question in the chat, that's fine, but you're also welcome to unmute yourself and show your video. And we'd like to find out from the audience how is substitution playing a role in your company's journey towards circularity goals? And we are fortunate also to have a couple of people today who have stepped up and willing to share that. Pat Harmon from BASF, John Schmaya of GreenBiz Circularity, formerly of Herman Miller, and Libby Summer of Bolt Threads, and more famously of Milo Mushrooms. So we'd like to hear from each of you as well. So would someone like to step up and offer some perspective on how substitution plays a role in your company or institution's circularity goals?
Lauren, this is Pat. I'll start. I didn't realize it would be called out specifically, but I'll comment. I guess we'll just comment on kind of like one piece of what we're doing at BASF. So we have a methodology called Sustainable Solutions Steering, and we've used it to look at the existing portfolio, but it's also integrated into the innovation process and our kind of gated innovation process that I think a lot of companies use. So fairly early on, but before we start spending very much money, new products are looked at. Not only for are there advantages and benefits to that material? I don't know, lower emissions, renewable raw materials, you name it, things that would have a larger benefit from a sustainability standpoint. But also, are there any yellow flags or red flags that might be an issue, either short term or long term? And so we really try to identify those early, and then also to try to identify, there are no yellow flags or red flags. And I think we have a staff of toxicologists, not only regionally, but also particularly in Europe. We have some toxicologists that, in my business that, work with us on these types of things to kind of ask the questions, or, what are the things you need to be looking at for a new material, out in the marketplace. So anyway, that's just kind of a little quick summary of kind of my input. Particularly, I think Eva had talked about the innovation part of this, and I think that really is an important piece that we kind of forget about sometimes.
Thank you, Pat, and I appreciate it's always fun to keep you on your toes, and you always have great responses. So thank you. And what I take away from that is the looking at this very early in the process, and having a comprehensive set of metrics or indicators to benchmark against. Would anyone else like to jump in here?
Lauren, this is John Schmaya. I'm happy to jump in quickly. I think maybe I bring a little bit of a different perspective to this, having spent close to a decade in the building products industry and then moving over to this role at GreenBiz, where I'm sort of looking, across the whole economy at circular economy issues. And one of the things that I think we see often for product manufacturers or brands is that, they've invested a lot in these sort of pernicious, problematic chemistries, right? They've already developed products. They're already out in the market with all of these materials in them that most of us would find relatively offensive if we were starting from scratch today. And the big challenges they face, or at least that I faced when I was in the role of trying to find substitutions, is one, a lack of sort of scaled options that were significantly better than the ones we were using. And two, even if they were there, sort of the challenge of overcoming the bias of already having used chemicals and learned how to work with them and learned how to process those materials. And so I think this, gets right back to Pat's point about how important it is to start from the beginning, right? To start with that innovation from the chemical manufacturer phase into the material phase. And hopefully start with products that are better, because replacing things is so much harder than starting from scratch with the things that are better in the first place. And then the other thing that I've started to think about a lot since I got into this new role at GreenBiz is, as we look at things like population growth and global pollution and supply chain pressures and all the things we're already starting to run into that are causing issues for the economy and wanting to transfer over to a circular economy, we know we want to circulate safe chemistries and better materials for sure. But I think one thing that a lot of businesses are thinking about right now is what do we do with all those problematic materials that are already out there, right? How can we sort of innovate around ways to continue to use those in as safe a manner as possible? So I think there's these competing pressures of trying to fix the products that we're making now, but also what do we do with all these materials that are already in the world and being used when they're at their end of use. So those are two things that are top of mind for me.
Wonderful, thank you. Those are great comments. Eva, is there anything you might want to respond to, or if not, we'll keep going. That might have triggered some thoughts for you.
I think those are all. It's really good to hear from people who are really practically trying to implement some of these approaches, because I think that's where we see where the hurdles are, right, and where the challenges are. And I think it's true that in a number of the discussions on circularity, what John said is really coming up is in terms of what do we do with these problem materials or chemicals that we have, especially where they might be present in materials that are materials that have been used in the past in large volumes, and we don't want to incinerate them all or landfill them, or so how can we make those circular while still minimizing risk of recirculating problematic chemicals. And I think that's where some of the challenging trade-offs come between policy areas, right, to increase recycling or reuse of material versus making sure that we have the sort of modern levels of protection for chemicals. And that's where policymakers, I think, need to make some challenging decisions, and probably companies as well.
Thank you. Libby, if you don't mind, I think John's comments are a really nice segue to the work that you do.
Yeah, they are. Thank you. Libby Summer here. I'm at Bolt Threads. We're a materials startup in the textile industry. I thought I would add a few perspectives from the textile industry's world, because all of this is very much coming up in our business. Prior to Bolt and working in brands, I've seen lots of examples of products that were circular in nature, so taking back end of life textiles and trying to reuse them, and they had hazardous chemicals that were above regulatory limits. So this is a real world problem. This is not just a theoretical problem. Taking that kind of experience, I've brought that to Bolt, and we assess every single chemical that we're even considering in our products before it can get anywhere past the lab stage. So it's really critical for us to know what we're using, understand the hazards, understand any regulatory risks related to that, and give that feedback to our research and development team so that they can incorporate that into their thinking as they design for a cleaner chemistry and for a future world where we do have circularity of materials. I would say right now that doesn't exist. We don't have a circular economy. We have a linear economy. And for those who are kind of interested in thinking about, well, what could that look like? I really want to recommend a report from the Biomimicry Institute called The Nature of Fashion. What I really like about that report is it acknowledges essentially the rules of physics, which is that everything tends towards entropy. So the idea that we can put things in a loop sort of indefinitely really is not the way things actually work in the world. And we see that, we see release of microfibers and waste getting out into places where it's not intended to be. That happens all the time, and that happens a lot in the textile industry too. And so with that, understanding of our materials and what we put out into the world tends toward entropy. how do we ensure that they, when they get out there, that they're not going to cause harm, or that the harm is minimized as much as we can. And I think this idea of assessing chemical inputs into the creation of a product is a really critical part of that. We really need to try to minimize the hazards and the persistence and bioaccumulation properties of chemistry, because everything is made out of chemicals, to quote one of our famous green chemical fathers. And so I think this area of circularity is one that, while is not as much focused on as the idea of does it biodegrade or is it recyclable, I think it's really, really critical to help us even have a chance of getting to a place where we do have a true circular economy.
Thank you very much. Those are great additions. Would anyone else like to jump into the discussion? Please feel free. We'd like to keep this somewhat informal. Otherwise, I could pick on someone who I know will have things to add and say.
Lauren, this is Pat again.
Okay.
I guess I have a question, maybe for Eva or others who are on the call. And this is in response to John's comment about what do you do with all the stuff that's out there, existing things that may have some concerns. And I guess my question is, obviously you have to prioritize what you're going to work on. You can't do everything at one time. And I guess the question is, what are the best ways to prioritize what needs to be worked on? And I'll give a hypothetical example. You may have some materials that aren't perfect, but maybe they aren't, in the great scheme of things, all that bad. So maybe they're a lower priority than something that's maybe a serious red flag that we need to adopt. But I would appreciate other people's thoughts on how you do that prioritization.
Eva, would you like to address that one first?
Sure, it's not an easy, I guess there's no easy answer, I think, to that, because there's different ways of prioritizing. But I mean, I absolutely agree. I mean, we should try and focus where the focus is most needed, right? So this could either be, I guess there's already a number of chemicals that we know have undesirable properties that are being regulated. And so, that's the starting point. I mean, I think we're still working on mercury and lead and all these things that we already know need to be addressed. But then I think, that's a good place to start prioritizing things that have already been identified as needing to be better managed. And making sure that we're dealing with those in an appropriate way in any type of circular model. But then also, I think we can combine this with the innovation side. So we have, the downstream regulatory response, that's sort of the traditional way, and a number of identified chemicals and substances to risk manage. But then also making sure that we're being more proactive at the innovation stage in terms of development of new chemicals or products or materials that we're not adding to the problem. So I think there's ways to I guess prioritize both of these areas. But I mean, of course, there's limited resources. But I think we won't, if we keep adding into the pipeline, we won't come up with solutions, enough solutions at the end. So. But maybe others have some ideas too about that. So.
I have a quick thought. This is Meg Whitaker. And the nice thing about Cradle to Cradle is that it does have the consideration of cycling built into it, with progressively harder level or higher levels of cycling. So if something is made, ideally not with a CMR, for example, it stays within its cycle. But what the OEC could do, not everyone wants to do cradle to cradle, and it's not for everybody, would be to prepare guidance so that if people do want to increase the recycled content of their product, particularly consumer products, that they know what are the appropriate analytical test methodologies, how to look for laboratories that actually know how to do that, because we see many people out there who go to a laboratory who have no idea what they're doing. They test the product and they're only looking for a subset of chemicals, and someone's thinking, oh, this is great, I'm increasing my recycled content. They don't realize that they've just introduced SVHCs, for example, into their product. So that would be a really great document to have, and it would really help industry. I don't know if anyone else feels the same, but there's a need for that out there.
That's a great suggestion. And also that's sort of in your purview, isn't it, Eva, with the good lab practices work that you do?
Yeah, I guess, yeah, it's interesting that that's brought up, because actually in particular on our work on plastics, so this is just focusing on plastics, but what countries decided that they'd like to work on next is almost exactly this, but specific to plastics. So to get a better understanding of what the different validation or certification processes, which of these types of processes are in place for chemical content of recycled plastics. So how are we, what types of different analytical techniques are some of these validation or certification methods using? What type of chemicals do they cover? Is it a really limited set, or is it going, is it much wider? How wide would we want that set of chemicals to be? How, for example, information that's passed along the supply chain informs these certifications or validations, or does it at all? But it's really this question of, even before we get to thinking of the safety of the recycled content and having confidence in the recycled content, what do we even know about the chemical composition of that recycled content, especially when we're getting into more mixed materials and it's not, a very closed loop, like water bottles, for example. So that's actually something that we're just kicking off right now as a project on the plastic side.
Great, thank you. We have a question here from Saskia on the potential policy side. Financial measures are mentioned. Eva, do you have good examples of economic instruments that can incentivize substitution? And also, I have an additional question that about how the work you're doing at OECD fits into the safe and sustainable by design in Europe. So first question from Saskia Van Bergen of Washington Department of Ecology. Are there good examples of economic instruments that incentivize substitution? And then connection to SSBD.
So on the first question, we recently had a workshop at the OECD in September, where this is one of the discussion points. We had a workshop on further measures countries could take to incentivize substitution. So one report that we developed, or that was developed for the workshop, was sort of scanning across other types of instruments, economic instruments that are mostly used in other environmental domains. So things like taxes or different fees, or sort of, things like cap and trade models, so this kind of idea, how they could potentially be used to incentivize substitution. So we haven't really traditionally been used, we being like governments, have not traditionally used a lot of different economic approaches because it's been more regulatory, sort of direct regulatory approaches that have been used. But we'll be publishing that report hopefully in January or February of next year. So I'll look out for that one, and it gives a nice overview of some of the types of models that economic approaches that could be leveraged by governments. On the question of safe and sustainable by design, I think this is where things are really connecting between different communities. So I think the innovation community, but also substitution community and alternatives assessment community and sustainable chemistry community, all thinking of these, from these different areas, are really all coalescing into the discussion about safe and sustainable by design. And sort of the safe part really, I think, leverages on the work that communities such as this one have done in the past. So we're definitely connected with the EU initiatives, and looking to see what comes out in the criteria that they're developing, which should come out by the end of the year.
Great. Any other questions for Eva? Any other folks who'd like to talk about how substitution fits into their own organizational circularity goals?
There's two hands, Lauren. Kathy Rudisell is next, I think.
Okay, Kathy, great.
Oh, hi, thanks. Hi, Kathy Rudisell, Safe for Chemistry Advisory. I had, I guess, like a question for Eva. Well, first I want to lead with my compliments because I really like the plastics report that's on, focused on the chemical perspectives on designing sustainable plastics. So you mentioned in your presentation. I reviewed it before, and I think it's a really great overview. And in particular, I really enjoy the trade-offs addressed at every step of the phase, because trade-offs are so important. One of the questions that we've had within the A4 community just recently at a conference was, would it make sense to provide guidance that's specific to industry to try to bridge these gaps between these different sustainability parameters? And I wasn't sure, and I was curious at your thoughts on that, because you did mention you're doing some other work in plastics, or have you considered doing a similar process for a different type of industry or different type of product that addresses these concerns?
So thanks for the compliments for the plastics paper. I think Lauren knows it was a way for us to get there. She was in the 2018 workshop. So so one thing that we're thinking of doing that's just sort of in the early seed stages is, so we had developed, as I mentioned, that document on selecting of a safer chemical. And so there's some thinking now is how can we look at that and potentially broaden the number of different, attributes that, different sustainability attributes that could be considered. And as I mentioned, I think, and come up with some guidance is similar to what we did with the selecting of a safer chemical. So are there certain different minimum targets for these different attributes that as a baseline, and maybe where some of these different attributes are more useful to consider than others. But I think this is sort of very early thinking about this.
Great, thank you. We have another hand raised by Hiram Mormon. Would you like to ask a question or make a comment?
Yes, thank you very much, and appreciated the presentation a lot. So my name is Hiram Mormon. I'm working for a company, a parent team in Belgium. And I had a comment on the question which Pat had on how do you define the priorities. It took me a while to reflect on that question, but we are involved in a project, in a very interesting project for the Belgian authorities, where they want to develop policy measures to incentivize substitution of hazardous substances. And they want to do this on an objective basis, meaning that they want to work on substances, on substance use cases, which are the most relevant for a certain country. So that's basically a kind of priority questions. But what you see is that when you start digging into this matter, is that that two things you will notice. The first thing is you will notice is that the priorities may differ from the one who asked the question. For instance, a priority for a downstream user, a user of a chemical, which substance he will substitute first, may be business related or impact related towards his market. This kind of assessments, while a research company or a research institute may look at the priorities from an opportunistic point of view. Where can I find a solution given my knowledge base? Now, for an authority, in order to do a priority setting, it needs to be objective, needs to be defendable, and then you go back to the basics, to the data. And then what you do this, you notice, and that's my second remark, is that the data doesn't really exist. There is no objective data on what exactly are we using those substances for, and what is the impact of the use of the substances, despite all kinds of dossiers and registration dossiers, etc. Still, when it comes to the details, it's very difficult to develop priority settings for substances you may want to tackle first. So I think that we cannot also underestimate Pat's question. How do we define priorities and on which substance we work first? Maybe the upside of the answer is there's so many challenges to work on. Maybe it doesn't really matter which one to take first because there's still a lot of work to be done.
Great, thank you for these comments. Great. Okay, I'm going to be in trouble if we don't stop here. This was a really great presentation and discussion. Thank you, Eva. Thank you, Pat, Libby, Saskia, everyone, and John, and for all of your comments. And let's see, next slide, please. Okay, just so you know, this webinar has been recorded, and you'll be able to listen to it, download it, and listen to it freely later. Please watch your emails for A4 announcements about upcoming webinars later this winter. And just to give you a heads up, there will be another A4 International Symposium in October 2023. We have not set the official dates yet, but this will be an in-person venue. That's what is planned. Next slide, please. Thank you. And we would like those of you, if you wouldn't mind just hanging on another minute, to take a quick poll before you leave. So thank you, Molly. Thank you, Jen Landry. And if you could just share that, answer that poll, that would be great. We're not going to share this with the group. We're going to keep it amongst ourselves and use it to continually improve the webinars that we share from A4. Thank you all so much for joining today. I think it was a really great topic, great discussion. Thank you, Eva, for all your preparation, and have a wonderful rest of your day.
Great, thank you.